Hello everyone, so welcome to my third video of trigonometric integration video series. So in this video we are going to solve trigonometric integrals finally. But I want to start this video with a question. My question for you is that when do we use double angle identities? And why do we use double angle identities? What is the purpose? Well, what double angle identities does is it takes sine square and it will give you cosine to the power 1. So it's like reduce the power, right? You had a square, now you have cosine to the power 1. Even before you had cosine square, but when you use double angle identity, it gives you cosine to the power 1. That's super important, okay? And the other thing is whatever you have here, it will double the angle value, okay? That's just a fact, okay? All right. Now, to do trigonometric integrals, to solve trigonometric integrals, solving trigonometric integrals means you are integrating trigonometric functions. Now, integrating sine x, okay, and versus integrating sine square x is very different. To integrate sine x, you can use basic integration rules very easily. You can quickly do it, right? But to integrate sine square or to integrate sine to the power 4, any trigonometric function with a power greater than 1 is very difficult. That is where we have to use these identities, Pythagorean identities or double angle identities. Now, the biggest question is, given a trigonometric function to integrate, okay, with a power greater than 1, which identity I should use? Is it double angle identity that I'm going to use, or is it Pythagorean identity that I have to use? So that's a big question. The answer lies in the use of identities. So here, now let me show you an interesting thing. If you can remember my last video, we converted sine to the power 4x. We used double angle identity over and over again, and we got a big result, right? Yes, we got a big expression, but we got cosine to the power 1. Every trigonometric function in the result was cosine to the power 1, because actually that is what double angle identity does, right? Okay. Now, so it seems to be like we can convert when we have a trigonometric function with a power greater than 1, we can use double angle identities and we can reduce power, right? Okay, can we do the same for sine cube x? Now we have sine square. If you want sine to the power 4, we can just square this. Then we get sine to the power 4. If you want sine to the power 6, we can use 3 here. If you want sine to the power 8, you can have 4 here. But can we make an odd power out of this? No, right? You can't take another power of sine square and make an odd power, because it will be always even, because you already have 2 here. Any number multiplied by 2 is even, right? Okay, so then that gives us a big clue, big hint. What is the big hint? I will say it as the rule of thumb. So the rule of thumb is whenever you have only even powers in the trigonometric function, you only use double angle identities. You always use double angle identities. Now I said only even powers, okay? Alright, so solving trigonometric integrals falls into 2 categories under that. Trigonometric functions that contains only even powers and trigonometric functions that contains at least one odd power. So if you can see there's a trigonometric function that contains at least one odd power, do not use double angle identities, okay? It's either going to be double angle identities or Pythagorean identities you have to use, okay? So when you see an odd power, it's Pythagorean identities. But if you see only even powers, you use double angle identities. Let's discuss about that odd power case in another future video, okay? But in this video, let's discuss how to solve integrals when we have only even powers. Okay, let's start from an example. Let's say we have to integrate cosine square. Let's see. So we have to integrate cosine square x. Now cosine square x is you only have even power. So what you do is you use double angle identity. Cosine square x is 1 plus cosine 2x over 2. So let's replace cosine square by this term. Okay, so we have 1 plus cosine 2x over 2. Now why do we do this even? Okay, let's discuss that after we solve this problem. So when we can take 2 out, so that's 1/2, 1 plus cosine 2x. Now let's integrate. So if you integrate 1, you get x, let's have brackets. If you integrate cosine, you get sine 2x over 2, right? Because of these 2, we divide by 2 plus c. Alright, do you see what's going on? Because we have even power in the trigonometric function, we can use double angle identities and we can get cosine to the power 1. Then after that, integration is super easy. Any trigonometric function with power 1, it's easy to integrate. Okay, all right. Well, I'm sticking only into sine and cosine. Okay, let's talk about the other trigonometric functions later. But any trigonometric function with sine and cosine to the power 1, it's very easy to integrate, just like here. All right. Okay, now let's look at another example. Okay, let's see how to actually integrate sine to the power 4. This is a very complicated integral to start with. You cannot use basic integration, and you can see there's only even power in the trigonometric function. So we know sine square, that is where we have to start, because that's the identity. We know we have to use double angle identity, so double angle identity is this. But we have sine to the power 4, so then we will square this, right? So then you have to square the right hand side too. So sine to the power 4x is actually 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2. 2 over 2 is 4 in the denominator. In the numerator, you have to multiply these two. Okay. All right. So let's see what we get. All right. So if what we get is 1 times 1, 1 minus cosine 2x minus, I FOIL the numerator, okay, and plus cosine square 2x, right? Okay, you should do that foiling very slowly. So this is 1 minus 2 cosine 2x plus cosine square 2x over 4. So this is sine to the 4. Now, is our purpose fulfilled? No, right? Because our purpose of using double angle identity is to get trigonometric functions with power 1. Here it's good, but here no. Still we have cosine square. How can we get rid of cosine square? Again, use double angle identities. So understand this. When you have a trigonometric function with an only even power, when you have to integrate it, use double angle identity over and over and over again until you get a result with cosine to the power 1. Then do the integration. Okay, so let's use double angle identity again here. So cosine square x is actually 1 plus cosine 2x over 2. But don't do this mistake. Be very careful when you use double angle identity, because you have 2x. So here you have the identity for cosine square x. So cosine square 2x is whatever you have here, it's double. So it's cosine 4x, right? Okay, so I want you to recall that from the last video. So we can rewrite this as 1 over 4. I will divide each term in the numerator by 4. 2 over 4 is 2. So cosine 2x over 2 here. And this is cosine square 2x over 4. Now I will replace this here. So this is 1 over 4 minus cosine 2x over 2 plus here 1 plus cosine 4x over 2. I replace that, divide by 4. I should find more space. Okay. This is 1 over 4 minus cosine 2x over 2. So here 1 plus cosine 4x, and this 2 and 4 will give you 8 here. Now this is sine to the 4x. Now if you look at the result, all the cosine functions have only power 1, right? Then you are done with double angle identities. Now integrate. Okay, so now integrate both sides. So if you integrate sine to the 4, integrating sine to the 4 is same as integrating this long result. Even though it's long, it's easier to integrate. Let me show you. So this is 1 over 4 minus, I want to simplify a little bit before I integrate. So I will divide each term in the numerator by 8. So it's 1 over 8 plus cosine 4x over 8. You integrate with respect to x. Let's integrate. If you integrate 1 over 4, you get x over 4. If you integrate cosine 2x, you get sine 2x. You will divide by another 2 because you have a 2 here. So that 2 and this all 2, 4. Here 1 over 8 is x over 8. Here if you integrate cosine, it's sine 4x, and you divide by 4, that 4 and this 8, 32. Plus c, don't forget that. So this is what you get if you integrate sine to the 4. Alright, do you see we did integration in the very last step? Everything else was just using that identity, double angle identity, right? So what is the final goal here, or how can we summarize this? Always remember, there are two types of trigonometric integration problems. One, when we have only even power in the trigonometric function, then we use double angle identities. Okay, other case we will see that in a future video. But what you do is, when you only have an even power, you use double angle identities until you get cosine to the power 1. Here in the first example, we got cosine to the power 1 in one shot using double angle identities just once. But here we had to use double angle identities twice, because when we use double angle identity for the first time, we end up with cosine square 2x. Now just here we had to use double angle identity again, because our purpose is to get cosine to the power 1. So we were very careful to use double angle identity here, because it's for cosine square 2x, remember that. And then when we use double angle identity for the second time, then we got something with cosine to the power 1 everywhere, and then we integrated that result. Okay, that's how we use double angle identity in trigonometric integration. So in next video, I'm going to solve more problems involving double angle identities and integrals, and after that integral, I'm going to show you how to integrate trigonometric functions with at least one odd power. Okay, all right, I'll catch you there. Thank you very much.